morning again. Now we have the lecture from Professor Vanderlan. It's a great pleasure for us to have Vanderlan here. I'm sure you all can learn a lot with Vanderlan and how to use your data in the application they can see, I'm sure. Okay, it's my pleasure to introduce Professor Vanderlan. Vanderlan has a degree in pharmacy at Federal University in Paraíba in 1973, master degree in organic chemistry in 1977, and a PhD in science in 1982 at São Paulo University in São Paulo. She did her postdoctorate in Virginia State University in 1992 to 1994. She was one associate professor at Institute of Chemistry in UNESP-Araraquara. And now she is a full professor in the same department. She was president of the Brazilian Chemical Society, and she has already received several awards, most notably the Otto Gottlieb Medal for her contribution in the field of the natural products in 2017. In my opinion, I think she felt very happy when he received the Gottlieb Medal, more than the several one others she received from other states out of Brazil. We sure in many evaluations they analyze the other medals. I'm sure she feel very happy to have a Gottlieb. Dosha Seco. She has more one Journal of Natural Products will have a volume to so that we can send many papers. Everybody receive the email here. It's will be one volume in honor of Professor Vanderlan. And let me see how many. Okay. The only one with this honor in Latin America in 64 years. Okay, about the research, she developed research in natural products with one emphasis in the search of secondary metabolites and peptides from Brazilian biodiversity and in medicinal chemistry of plant. Please, Vanderlan, welcome.
A great pleasure to talk, but also a challenge because Fatima invited me and I gave an amazing title for this presentation, trying to combine chemosystematics that is like a legacy of Professor Bolzani, and try to combine with the is up to date today metabolomics, omics. Most of the Brazilians that work on natural products that don't know about metabolomics. Just put the name. It's a very nice tool, but when you analyze what the information that metabolomics can give us, similar traditional chemosystematics that I will try to explain during this presentation. So I would like to say, Fatima, it's very nice to be here, and also because we celebrate the 20th week of National Week on Science and Technology that I don't know, but it's a problem nowadays. We need to be conscious about what represents science for a country. Along of almost 70, 60 years of development of science in this country, that after the Second War, we are developing so bad country with so analphabets, ignorance, no companies, no science, and you have a tremendous advance. And now, after 4 years, you need to go to the Ministry of Science and Technology homepage and to see how much your university and all universities in this country have on developing science and technology, because you are a federal system. It's not supported by FAPESP as USP, Unicamp, and UNESCO. So, I can't start my presentation without talk about this. That's very important. You see, I talk this in FAPESP. The new generation try to see only the cellular as like salvation, don't care about anything. Science and technology depends also on you, that is new generation. It's very important for we change this conception. Even you change the president, the money is still the same. You don't have money. Without money, it's impossible to develop good science aimed at technology and innovation. So sorry, but it's necessary to talk about this. Thank you. And I put this title. That is a very ambitious title because I have so many lectures. But when we talk about the chemosystematics, that I think is very important because Fatima and myself, I think, was the first students of Professor Bolzani to develop this new idea or new studies on natural products named chemosystematics. That sometimes that is a new confusion with taxonomy. It's a classification but based on chemistry. So I try to explain to you today something about this, how to use molecular diversity, what the significance of this, how to make useful markers, because it's very important when you think that natural products in Brazil, that you have a tremendous biodiversity. It's so important for bioeconomy. If you know taxonomy, maybe you can contribute a lot to developing new bioproducts in Brazilian biodiversity. So I will try to show some examples that I put in the class. I like this slide, it's very old, but I think it's very important when you see natural products. In my mind, it's like so many molecules. It's the most important and most perfect chemical lab. So it's very important to understand nature. If I understand nature, we are be able to understand the chemistry and contribute with this fantastic library for human. Maybe now, after a pandemic, that maybe 1 century after the Spanish influenza, nobody can believe that you pass for the same problem with all advances that you have in all continents. So it's very important. We all try. It's just to see the past, how fantastic is this laboratory to give us all information that is necessary because chemistry is so important. All that are around us is chemistry. So it's very nice. It's a good example why you don't have one antimalarial if you are developing country or developed country that is not green. You have some friends. You have here around Campinas so many species. But this is not mine. It's not mine. It was developed in China. That is a very traditional in natural products. I don't know if someone knows about the Instituto Matéria Médica. It's fantastic. You see all products that is isolated in potassium lab, in amoxinase, everybody is cataloged in that library, in these institutions. Fantastic. So this is traditional, you don't have. It is very nice because when you see the structure, all of you see a very unusual molecular model, and you can spy so many molecules because you have a peroxide. Fantastic. And this is the history about. It's a very nice review, it's old, but very nice review that you can see the timeline about the development of all the studies that China dedicated to this compound that nowadays is useful to treat malaria. If you look the past, you don't have malaria anymore, but now you have malaria again. So just to show to you that it's very important because nowadays when you talk in metabolomics that you are in the omics era, it means that you dominate the genes and you dominate the translation that cells doing in organize to see how you can produce this kind of compound or how you can imitate nature. This is very important. So, Choi is here. I think he knows about this because he's from a report lab that is retired. And he lived in the United States, gave a very nice part for him because he worked a lot to develop this complex pathway dedicated to alkaloids that is a very important class of compound to see how one can see the nature and copy to make the lab synthesis that can reproduce nature. That is not easy. Even nowadays, that's so many you need to see to be green, and most of the lab is not green nowadays. So this is the timeline that I prepared this, and I like because it has a whole idea about all compounds that change the history of humankind. You count the fingers. When you see, that is I think it's a slide from the report that you have isolated more the 30,000 million compounds, several classes from terpenes, alkaloids, flavonoids, etc. And you see the evolution in the plants. And you don't have, in Brazil, you don't have no studies developed in this country that has are very powerful natural products. This is one to have a glance in the future. Why? Ele, quando ele put catopril, that we put now catopril from Brazil. Yes, isolated from Jararaca. The Sérgio Ferreira, I don't know if you know this name, he's like very famous, was very famous in medical. And he isolated this, but you don't have the patent, because when we go work in this, he was a PhD in UK, and this is a property of the company that produced this. It's a billionaire drug nowadays. And also the last one that I should have forgot is from maconha. That's Professor Carlin was for the policy, because the still president told that he worked with maconha, and maconha, essa coisa de maconheiro. Remember this, that all journal put Professor Carlin so old going to the policy. So now we try to explain to you the subject of talking all day today. It was in 1999, FAPESP organized a special issue in the magazine of FAPESP about Professor Rotti. Because, and I liked this article, because it nature's organizer. Fantastic. Because he had that conception. Try to study nature just to understand how chemistry can contribute for us to understand the earth and all process that you have in this planet. And you are one species among so many species. Carlos Fioravanti, he did this report. He was the report of this magazine and this communication. And also, I don't remember of this, it's very old, this, it's not for our time. When Professor Baturi was young, he was that sometimes most of the new generation think that Professor Watt was only the scientist in the Block 1 in São Paulo. And also in São Paulo, study scientist, but now he was a research that was go to field trees to understand nature and collect plant material. It's amazing, but it's true. It's a real photos of him. And also, Fatima and myself, maybe the first students that changed to Fatima did a direct PhD. Okay? I did my master in phytochemistry, and I worked with plant organisms with just one compound, one electric beam, and then I take my master with just one compound because it's a new skeleton, and that's what is a laser proton. At that time, Professor Botticelli start to try to see how he can contribute to the phytochemistry, or to not, or contribute how to use this fantastic library to understand nature. So Fatima was first. She worked with chemosystematics mais famílias vegetais caracterizadas por marinas. I think era Butalis. She specialized in Butalis. And after that, when I finished my master, I decided to study chemosystematics. At that time, when I decided to study chemosystematics, that will change completely. Fatma was my co-supervisor. Yeah, because at that time I moved to Araraquara and I was with two kids. It was very difficult to go all the time to São Paulo. So Fatma was my supervisor because she was the first and we discussed a lot our work. So this is a very strong correlation, not only because we are on natural product, but we work almost together to try to understand these new focus of the science on natural products that idealized by Professor Bolzani. So this is the first work that I published that time so long that you have, and also Arnaldo. I tried to looking for a photo of him, but I can't. Because during my master, he is from Manaus. He isolated the plants that I did in my master. And also he was one involved in chemosystematics, and we worked together. It was very important at that time. And it was fantastic because I learned a lot. I have idea. It's not like that you go to the lab, you work with the species, you dominate the techniques that you isolate or you can have a master and a master. You have an idea about the name of all kinds of secondary metabolites produced, depending on the taxon, it depends on the local where these plants grow up, and you have idea. It's very important to use as taxonomy. So this is very complex, but we worked in GT analysis. GT analysis is an order where when you have this Dalvin, the partner is very fascinated also for Dalvin because it's a map. It's like a construction of a tree, and you have a position of the order that aggregate families by biological or morphological characters. That's completely different from chemistry. So the idea is how to combine morphology, biology, and chemistry. If chemistry is all is the base of the life in the earth. So we work and was a very specific GT analysis that produced this kind of alkaloids. That's indole-terpenic alkaloids or indole-alkaloids. It's a very complex class of secondary metabolites. Because my students fascinated from them records. Every year to study with Fatima. Because can you believe this tremendous complexity that you have in this kind of compounds that originate from this part of tryptophan? And also, if you see this, it's from iridoid. It's very complex. You have almost 4,000 compounds nowadays. Isolate from these classes, different classes, because they have almost more than 20 rearrangement of when you have the first linkage of biosynthesis, have so many reaction that is modify the structure, and you have a tremendous kind of importance in many of several structures that you see in that pipeline about the vincristina. Vincristina is a alkaloid. Salaricina is alkaloid. There are several indoor knowledge, very important for medicine. And you just try to organize all this information, and you have analyzed because nuclei is here, because they have adapted nuclei Loganiaceae or Rubiaceae, nuclei Rubiaceae. But this only compound was isolated until nowadays only Rubiaceae. Who knows, you can start chemosystematics in this and to see what happened with the biosynthesis of these plants in order to prove if this is from this group or that. So we produced this result. It was very important because we started establishing several correlations. And this correlation was very important and was responsible for the indication of Professor Otto to Nobel laureate. Why? Because they create an equation where you can use, quantify the structure, molecular structure, using number to identify how the complexity of the linkage carbon, oxygen, or carbon, nitrogen, carbon, sulfur, and also to calculate the oxidation. So you have two parameters to establish, not only to say, the nature is nice because it produces this alcohol, that alcohol. You quantify. Based on these data, Professor Cotelido was the only chemistry until nowadays in this country indicated to Nobel laureate by another Nobel. Professor Hoffman, America, indicated Professor Cotelido twice. In that capacity article, that was indicated few times, but I want to know this third time. But the first and the second was indicated by Hoffman. It's very important. So we established all these criteria. Why it was important? That time, Robert era the most important taxonomist of the Rubiaceae family. That's important because the family of the coffee, so many species that belong to this family. So to establish this classification, and also Robert sent a message to Professor Watt, and this was in I don't remember that I went, the first time that I was give a lecture out of Brazil at that time, to present our data, because it should be so important to confirm the new taxonomy revision that Robert, very famous, was finished and published a book. At that time, he tried to understand that subfamilies that you organize like this is completely in agreement with our chemosystematic data. It's amazing. Completely combined. The data is very important, very strong idea to confirm the taxonomy, because chemistry using taxonomy. So it was very important, and this revision was the classification, and you contribute for this. This is a very important contribution of our work. This was when I was in this meeting. I don't remember. This is another lady that worked a lot in chemosystematics after the last. We started, and I think she finished. Yeah. So Iridoid also is very important because you have several importance to not only for this function as to contribute to see or understand the indole alkaloids, but also you have in several plants that you see in Amazonia nowadays, that the composition is iridoid. One of these is this olateiro that is all pharmacies that you go in north regions, in Amazonia, Belém, Macapá, Amapá, you have this. This is a Calicophilus pusseana. It's a very nice because it was a thesis and you study a lot of this plant. So this project was discontinued because it was the from Natura. Natura had so many interests in this, but when see that you have a composition and patent by Christian Dior, that is very important and powerful company, they finish because document doesn't have our interest if you have this from a property of a very important company outside of Brazil. But it's a very nice to study their views. So this is like a whole idea that I talk about the traditional chemosystematics use that is a green map, and you see all kinds of alkaloid, only the basic structure that you need. Isoquinoline or indole, piperidine. I worked a lot with piperidine in Araraquara because we talk about the cassias in Senna, that is very beautiful flowers, and we work a lot of nice work with patents also. One work with Europharma about this piperidine alkaloid long chain. Important that no everything is patent in the what I said. So we are here. Nice because the contribution of a work showed importance that even you have different classes in the alkaloid that is very sophisticated in terms of biosynthesis. These are advances located correctly when you evaluated this map based on taxonomy. This was the most important book that I think you are talking about. Very nice because this is this book that you have the base of chemosystematics. And I love it. This phrase when in 1998 because that each plant contains hundreds of substances and one of them may be more important than another. That is very important. He was fascinated by nature. That I think is very important for us. All scientists must be fascinated by the research that you embrace. It's very important. So this is a legacy that this professor gave for me, for Fatima, for Johnny, for all students that passed in 11. Jiva, and I believe Jiva was more recently. You was to me, when did you remember that when I like to write before to be a scientist, I'm trying to write a book now, and I have a book in you and try to submit the program to Equally, and if it's approved, maybe we can write a book. I would like to write a book about cenas da universidade. or about poesy. I like to write notes. So when Professor was 7 years old, I wrote this. I have a definition, joy, sorry, because I don't know. Sometimes it's not a translation when you have a poem. Doesn't work. I met Professor Bolzani, mestre dos mestres, o meu querido professor. Gostaria de presenteá-lo. Mas que presente vos dá? Quisera eu, mestre querido, em um momento de devaneio, voltar o tempo, retroceder no espaço e junto ao mestre querido, e tudo de novo começar. Cursos, estudos, tese, e como diria a sensível Cecília Medeiros, ancorar a vela do meu barco junto ao rei do mar. Foi quando ele fez 70 anos, que a gente fez uma festa lá já tinha a casa da Vila Madalena, porque o Jorge, meu marido, já tinha ficado doente, e aí eu tinha pedido o apartamento e fizemos uma festa dos professores lá em São Paulo. Então, esse é o Otto que tentou reorganizar tudo isso. E para que você entenda a natureza, não basta saber sobre célula, como ela se forma, não basta saber sobre a morfologia de tudo que nos cerca, das espécies que é fascinante que nós trabalhamos, nem basta saber só da complexidade molecular que é feita a partir de uma reação simples, mas fantástica, que é a fotossíntese. Não basta isso, mas tentar organizar. Isso o professor fez com muita sabedoria, com muita elegância, e nós tentamos seguir. Eu tentei continuar ainda estudando os alcaloides indólicos. Essa foi a Carmen, que ela é professora da USP de Ribeirão Preto. O trabalho dela foi muito interessante, porque era aquela planta, uma planta lá do Nordeste, da Amazônia, que tinha alcaloide, e ela, naquela época a gente só se interessava por atividade, que estava em moda. Tinha que ter alguma coisa que tivesse atividade para nós, se não tivesse, não sei. Só que mais do que ter atividade, não sei se vocês lembram lá no esquema passado, isso aqui é um alcaloide indólico, todos eles, mas esse aqui particularmente, os abertos, é como se você tivesse uma reação. Esse aqui é o precursor, vai reagindo e fecha. E olha só que coisa fantástica para vocês que fazem aula com a Fátima, que é a professora Nova Sen. Isso aqui tem alguma coisa a ver, né? Por que você tem uma glicose aqui que nunca tinha visto isso, né? O professor Zenck, que foi um grande, vocês estudam biossíntese do passado, estudou muito a biossíntese, e ele propôs todo esse esquema de biossíntese para os alcaloides indólicos do tipo corinanteano, que eu falei que é uma espécie muito complexa. Como você tem a triptamina, que é triptofano, que descarboxila e forma triptamina, e reage com o cefalimidoide, que já é um amiloide aberto, aquela reação, são reações muito específicas que vão formar esse tipo de precursor básico, que é o mais simples. Olha a complexidade desses alcaloides. Até os mais complexos, como os anfenatanos, os tabernamitanos, que são uma complexidade enorme. Porém, aqui, a coisa mais fascinante que mostrou, e na época o Zenck mandou várias cápsulas, porque ele queria que nós pudéssemos pegar essas plantas para ele reproduzir, testar, é porque ele queria provar essa sequência metabólica que até hoje existe nos livros de biossíntese que vocês estudam. Porque tem algumas que foram provadas, mas nem todas. E por que isso foi fantástico? E ele ficou apaixonado. Porque, olha, vocês têm aqui uma substância instável, uma hidroxiamina. Olha que coisa mais linda que a natureza faz. Isso é um grupo de proteção. Quem faz sim sabe que reação é proteção e desproteção, proteção e desproteção. Então, isso aqui é uma reação de proteção fascinante, e ele ficou fascinado. Mandou uma meia dúzia de cartas para o professor Otto e para a gente. Tentamos de tudo ver se a gente conseguia fazer essa etapa para ver como isso acontecia, mas aí precisaria estar em bloco, porque para você fazer biossíntese com plantas da Amazônia é quase que impossível. E esse trabalho ficou parado, e depois de muito tempo mandamos para os Estados Unidos e ainda chegamos na estereoquímica, porque antes a gente não tinha noção, como ele sempre propôs, e isso aqui é um dado importantíssimo de contribuição para a química de produtos naturais. A Aline Coqueiro até tentou ver se a gente conseguia mapear a estreptosidina, glicosidase, que supostamente estaria envolvida naquela etapa para fechar e ter essa proteção, e nós não conseguimos. Então, isso aqui ficou um trabalho que até hoje é uma interrogação. Eu tenho ido para o meio da Amazônia, porque eu faço parte do Ministério da Avaliação do Instituto de Desenvolvimento Sustentável Amirauá, em Tefé, no meio da Amazônia. Até tem, mas a gente não tem condição de... Teria que levar uma parafernália para lá, para pelo menos a baixa temperatura, pegar tudo e depois trazer. E aí eu fiquei velha e tenho que passar isso para vocês que são jovens, né? Mas isso é um desafio lindo. E quem fizer isso vai ter uma contribuição enorme para a química de produtos naturais moderna dentro da era metabolômica. E isso aqui foi como eu comecei em Araraquara, trabalhando com Malpighiaceae, principalmente por causa dos esteroides. Aí veio um grande projeto, porque é muito importante ter grandes projetos hoje, para você. É alto investimento, né? Pesquisa de produtos naturais nessa área é muito cara. E nós montamos uma estrutura no laboratório com esses grandes projetos que poderia começar a fazer estudos de metabolômica, já que é o assunto, porque metabolômica subentende um investimento muito alto em equipamentos que possam fornecer dados coletando folhas. Esse aqui é o grande desafio. E com isso, teve uma tese que a gente chamou muita atenção de me aproximar da metabolômica. Eu sempre tive um pouco de pé atrás, porque muito falava de moda, na realidade, isso aqui é sistemático, algumas coisas. Mas para ver, você chegou, vocês não devem lembrar disso, mas isso foi uma coisa muito complicada, que ganhou o mundo quando o pessoal usa muito santo daime, até hoje, nos rituais religiosos, que pegam essas plantas que são alcaloídicas, mas não tem cuidado, porque o conhecimento tradicional faz com que aquela comunidade conheça a espécie da planta, e mesmo que não saiba a química, ela tem uma noção que aquela planta produz. Até porque eu acho que foi assim que começou a agricultura. Foi morrendo, que você selecionou algumas plantas para que todos os humanos possam se alimentar. Se vocês gostam de leitura, tem umas leituras muito interessantes sobre a origem do homem e, principalmente, a origem da agricultura. Sorry. Sorry. It was a very problematic and was published at that time because one guy killed her friend in ritual, something wrong. So they suppose that at the time that the plant used, but it's very important, I think it was a journalist, I don't remember what. That plant used should be Banisteriopsis capii, that's Malpighiaceae. As Banisteriopsis capii to kill something wrong. Why? Because Banisteriopsis capillary is a traditional plant used by Indians, mainly in South America. Not in Brazil is very common, but in Peru, Colombia, Mexico, several Indians of this region use Banisteriopsis capillary. And what's the composition that we have in Banisteriopsis capillary that if you take the wrong plants, you can cure? Because they have specific tryptamines. Not all, but someone is very toxic. And in Banisteriopsis capillary, that's traditional. You don't find the tryptamine that is very toxic. This was a very problematic also in the United States because of, at that time they had some accidents in the United States which completely forbid this. And we'll try to collect these plants to see, and this was a master and PhD thesis of Massal. He take this plant from my land, Paraíba, classified by a specialist, that you try to see different species, that is capillary and also mucronata, and they may be that guy that used in the ritual that was published in Veja was not capillary, was mucronata, because you don't have capillary in this plant, you have mucronata. When you see the morphology the same, but it's completely different from the chemistry, if they are in the same group. And okay, you study? Because you have interest in acetylcholinesterase inhibitors for a long time, and you try to use this plant, and you isolate several different compounds, lots at that time. There's a nice structure. I don't have interest in this kind of. Okay, no, this is very important. When we finish this thesis with all methods, we send everything was established. I prepare a document I sent to the Ministry of Health in Brasilia, try to contribute. They okay, the vision is permitted, and you need to respect. That is obligation for the Ministry of Health to try to have some instruction for the population, for the religions, that you need, if you are going to drink some material, some extract, you need to be careful when you don't know about the chemistry and about the species. I think this is chemosystematics. This is all the compounds that you have isolated, all methods, and this was the problem. And you see, because the Indians use ayahuasca, because it's hallucinogen. And most of the tryptamines are hallucinogens, but this is very, very toxic. It's impossible if you don't know the species. So it's very important to understand all the chemistry of these compounds. And so this also, and you may study several different in order to contribute to our country with the people that are religion and don't believe in science. And do not believe in science, at least you believe in the ministry of this science or in the third one. It's necessary to take care. Until nowadays, you need to take care because it's very similar. And I think 2021 was one accident in Manaus, in Amazônia, because they some people drink, and in this drink was a mixture. It's not KPI, was Bancerios mucronata. Very, very, very serious. So, it's all the work that you have developed. It, it was published in Journal Prod with Mark Massal, and also you need to take care if you, if you drink KPI with psychosis, it's a mixture of dying. I know in Sucata that you know, he was one out and he drinks this is very horrible, very bad, the taste is not good. So this is the ayahuasca. This ayahuasca is completely different from Tetaniteres, and this is the difference of the pay attention about these vitamins that you have. So, it's all, and you know, to continue to work with Malpighiaceae, because I think it's very important. And this is another species that you have isolated. Now I think I am in the finish, no? Oh my gosh. So, we try to, with the help of Emerson, to start to study, because some plants of Malpighiaceae contribute to the use the economy of Brazil, because Brazil is an agro, and also you have a very important cow.
Cattle.
And ribbon. Very powerful. So this you see when this kind of maybe cow or another kind of land or something that you eat, this plant, this Malpighiaceae, they become very dangerous for this kind of animals. And also, they diminish the values because you can export. In Brazil, it's a big exporter of meat, you know, from China, from several countries, in China. This is during the second that you have together, Fatma also as the coordinator of the UNESP. That is nice because it's a big project. Several, you have a very nice, and this is important because most of our UNESPs is by young generation. So with this project, we try to evaluate simply based on bioeconomy, the science. Good science can generate good economy. So this is the base of our project. In this project, we start again with Malpighiaceae. Now looking for plants that are involved in the agriculture and also the chemicals of cows and they because it's very toxic. So it was a very this is an excellent student, China, and now she's in California and work with Peter the first time. Why? Because we applied a PhD, a postdoc for her in Japan. And I think 3 times, and was rejected. That is not good. Now he's in the United States. That's very important. She's very good. Can you believe it was collected 30 samples of 50 species instead the whole time for to study to where is the countries of that you have farms. We discovered also that this is the very good kids, but the difference is not as bad. I tried to pick up that today, but the difference so bad now. It's better than this nowadays that situations not good. And this was the page she published. you have an idea about all the use that we know metabolomics. That when I talk now, you try to use all compounds that were isolated and I published several classes. And also, in traditional chemosystematics, they realized that by Professor Baturi, that you can calculate skeleton and oxidation, and with this kind of number, you can formulate genealogy, phylogeny, involve taxonomy, and also chemistry. That's perfect. So, for this, the difference nowadays is because you don't use equation number for skeletal or oxidation, but you need to have all these structures very important, very expensive. But if you don't have it, but it's good math, it's almost impossible. How you can produce metabolomics? Because you need to have some amount of material to isolate all chemical, or you can have access to this database. This is another really required to organize a database of natural products in Brazil. So she worked, and her work was very nice because she discovered maybe most toxic this place that is usually in farms where you have cows. You have something that all was detected. That is very toxic. And they studied this a long time ago. That is, did you see this? Do you know these compounds? It's fluoracetic. You have mono, 2, and 3 fluoracetic acids. That is rare, but you have in some plants. And this is lethal. In some part of the country, we found these compounds mainly in these species. And sometimes you can identify, you see, if you are a modern, you can identify, but I don't know. Everything is obvious, and you see that it's very toxic. You need to take care about this. And also, if you have a farm with the cows, if this metabolites is very toxic, you have a work produced in 2017 in the United States. Sometimes it's accumulated. If it's accumulated in a species that you need to eat, it's amazing. So it's a very nice composition. And now you see that identify the Malpighiaceae. So the modernization that you need to know metabolomics is because you use some network, and one very important that you know, that's free, it's nice, the GNPS. That all is an international database that's supposed to have all compounds deposited there. So it's like you have a chemosystematic again, it's not necessary to go to the lab to use all HPLC, that is very expensive solvent, to isolate 20 compounds or 50 compounds. When you open the magazine, you see that the Chinese isolate 150 compounds, the same amount of material. Think about. So it's very important because when you have this, you are be able to identify different compounds and associate it to the mass. that is more frequent than the NMR. The NMR, you need some more material, more sophisticated, but this is very important. And if you have this data, you will be able to look for in this platform and to see the correlation. It's like a modern chemosystematics that in the past you did like chemical errors to calculate oxidation, to calculate, and now you can use sophisticated equipment. So she did this work, and you have a lot of, and she decided to organize that is very, very difficult to see this, but this is a phylogeny that you use the chemistry to aggregate species that have some taxonomic affinity. So it's very important, more than 200 samples, and this is the work that is modern chemotaxonomy. Can you see that you're looking for? This is fish you use only 2 species in the Africa. Why is it important? Because you suppose that in the past, Professor got to work a lot about the continents. That if the continent was together, when they split these continents, you should have the same composition. Maybe after that, you have some difference to it, and also it's fundamental, but it's important because you have only 2 samples. It's very difficult to collect blood in Africa. It was collected by a postdoc that was in my lab in some Cameroon, but there's 2 species. It's sufficient to compare with all that we have collected here. And this is the chemical composition that you have, and this also talks to cattle, but you can also identify and you see just this compound here that's supposed to be not toxic. This is one idea that we suppose that this plant was responsible for the fluoacetate. Fluoacetate. Oh, fluoacetate, yes. Okay. But we needed to prove. So, this is, you can see, this is the second that you see, but all you see that you can organize these samples in 10 phylogenetic groups. And these groups by chemistry. Let me take this is the cluster that you organize, the column that you go to the library with class of compounds, and class of compounds that's clades, and you organize these clades, and so you have phylogeny. It's easy when you compare with the past, because in the past 2 years collecting data to evaluate and to have phylogeny free. And now you can have a phylogeny free. Just go to the library of GPS and also to organize data very small amount in mass to prove, because sometimes you don't have all compounds in the database, but you have the same skeleton. You have it's very difficult to find a new skeleton. Most are the common skeleton that you have isolated, that is the organization in agreement with all biosynthesis studies that you have performed nowadays. This is that you see. This is nice because when we did this, I didn't realize that Malpighiaceae should be very rich in iridoids. And this was proven in these studies that you have several iridoids present in Malpighiaceae. This is a very important data for chemistry, for chemosystematics, and also for drug discovery. Because you have, now I'm not anymore here, I was 12 years in the board of L'Oréal in Paris, and they have a very interesting class of natural products for silver aging. It's amazing because less you have interest, like oil. It's completely stupid compared with the force industrial that you have here. Why? It's supposed by several documents that after 60, even you don't have so much salary, is most are established and use a lot of cosmetic, many cream to the face. So it's amazing. You have a subject that is a first page in the Folha de São Paulo, talk about the low economy for silver age. That is completely contrary of the big companies that invest a lot of money in search of new products for silver age. So you can see all the silver economy, you can map all things that is okay, and you have organized this in a very, very complex chemical hierarchy tree. That our tree in the past was not so beautiful like this, but was very similar with the same data. This is beautiful, but you see, it's very complex. Maybe we are what wasn't possible to produce a sophistication like this, but you can separate. So, if you calculate and you put research in all this database, you will be able to establish very complex, so this is all phylogeny according to compounds that you have isolated, according to the place where the plant was collected. So means all kind of compounds that you can have. So you have this, it's like a chemical and taxonomic photography of the Metabolomics. The Malpighiaceae Malpighiaceae studies. That is a plant of interest for agriculture, interest of for rituals, many rituals. And this is parafernália, não sei como falar isso em inglês. Parafernália desse universo molecular, where you can identify, because they call the program, you start the program, you see the class of compounds. So it's quite nice and easy. Even you have a sophistication behind this, it's very important because of the belief that we evaluated. The countries of the structure that was evaluated to have idea where they can contribute for the taxonomy of the family. That is fantastic. This is a summary that I put in the beginning of the presentation of Malpighiaceae also. That is very important. You need to have samples. This is very important. You need to have a lot of material. You can have concentrate, but if you find out in several regions where geography, you have different geography, different climates, different so many difference, and be able to have more information when you submit this to looking for the class of compounds that you are identifying that samples. So if you do everything this, you will be able to have phylogeny and dysphylogeny. You can see what compound is responsible. You contribute for the biology. You contribute for the chemistry, but the most important contribution is if you are interested to bioeconomy. that you're looking for natural products, compounds that are able to some technology, and you don't have too much. You have a mixture, you have place, you have a millionaire market in Brazil, and a couple of years, açaí. Açaí is a tremendous market to Brazil nowadays. They use the book that is most as flavonoids, because okay. They put the bark, então,
I talked today about açaí.
muito aquele livro de fresh is more important compound than you have in açaí that I don't like açaí, so okay, that we use as food for that very amazing. You have several places in Amazon that Bacuri, you have a bark like this, then you have practically beautiful amount, one time of flower. That's very expensive. They and use the Bacuri to produce shoes, cream, sweets, I don't know. This is the final. This is preparation of article, but it's nice to look at here because you have some problems with carbons that related to this around this, to produce one more, but the similarity of the compounds, mainly in oils, you need to study more in order to see if you have in reality this difference that is shown here, that you see, that is difference, because you can't see this difference yet. Very important in the chemistry. This is conclusion. I think it's very important to look at systematic tests, even in the metabolomic area, that use sophisticated math and MR. And MR should be nice because you have not much work on chemosystematics with the MR. You have a lot of math. Because it's easy, no? If you go to the library, most of the information is based on math. That's okay. It's very heavy. You need to, all this is very important, and you are in our lab. How to extract material. Before to be green, that is very important, this extract is quite close for the portion that they use it in the windows, or you use it as medicinal plants. Because you don't use extract, you extract it, you concentrate, you don't have a solvent. If you go to the pharmacy, you don't have anything prepared in a chloroform or chloride, etc. So it's very important to, nowadays, everywhere in the United States and also in Europe, to work in natural products open green. Otherwise, no, everything again. And the statistics. You don't have too much work with statistics, it's very important. If you don't have too much follow this, if you isolate 50, 60 compounds, it's nice to be looking for some biostatistics. What the contribution of this? No. I think in 2020 was the novelty. To me, continue the same for, however, to have the sophistication that is nice, that is typical for the evolution, in development of humankind. We need to all time we work and looking for contribution. And I don't know, so one of you here can, in fact, continue the work of the Professor Otto that he, until nowadays, is my inspiration, not only for natural products, but he was a very, very science. I remember invite them to be direct role. Nowadays, we start, no, I'm going to be direct. Here, no, this is not science. Science is dedicated time. It is fascinated. And we need a new generation to still work on natural products. That is fascinating area. And Brazil have 6 different biomes. And we have like a drop of knowledge about these biomes. This all finished. We moved recently. We are working on peptides. That is also very important because long of almost 100 years, we work only in small molecules. Peptide is very important also. It contributes not only for chemosystematics, but you have several reviews recently, one in Nature, about the preclinical peptides in preclinical phase. This is also the that you have. Now, according to according to Academy, Brazilian Academy of Science, all time that you need to talk with the young generation, you need to put this, there is the objective that was designed in ONU to be reached in 2030. There is 17 objectives. That is very important to improve the life skills for all being, because like all of you see the problem that you have now with climate change, so many wars, terrible. So all this is very important. But if you see, most of this relate with nature, relate with natural products. You need to protect our neighbor and to understand our neighbor. To understand our neighbor, you need to understand chemistry and to see how is fascinating this fantastic lab, how can produce one cell, single cell, produce hundreds and hundreds and hundreds of secondary metabolites. It's fascinating. This is a that I put here because Professor Watson gave SBK data medal. It's very nice because it's one way to incentivize young generation and also natural product chemistry in Brazil. And the first was for us. And you were student, not? Yeah, was a student. Oh. This is collaboration. Have collaborations in Brazil and also outside of this, at several collaborative work. Without support, this be possible in here work. Then you have also some international collaborative work. This finished because we last year, because we have money, and last year we finished this project and they develop money. This is terrible because it's in the trend and was not very deep. You don't have students or professors to change this. And also, I don't think you remember when this was published. Então, I would like to thank you and thank Fatima and Scott and all of you to invite me. And also, in 1998, I wrote this document. Os sonhos existem de pessoas fantásticas que dedicaram suas vidas ao entendimento do nosso planeta, de tudo que nos cerca, sejam também os nossos e todos aqueles que acreditam que um dia seremos uma nação socialmente mais justa e menos desigual. Muito obrigada e agradeço imensamente a Fátima por ter me convidado a esse vídeo. A minha presença é sempre uma grande satisfação de estar aqui.
Many questions, many comments, but of course we don't have time. But to our students, this picture was drawn by a student here. Yes. I forgot the name, do you remember? I think it's João Batista Paulo students. I don't remember. But anyway, about how is important is for our students. How is important you know, only know your project, you know several things, because you know several classes of chemistry. And you don't know only your class, you know several classes. And you know the biosynthesis of all the class. What's important? Vanderlan said about L'Oreal. When she had a contact with L'Oreal, Natura came to us. I'm sure you know where can I find a similar compounds, but it isn't the same. Then I can prepare the same cream, I don't know which one, shampoo, I don't know. Can you help us? I was there. It's exactly because I have this knowledge about several families. And of course, Professor Norberto, because could help how to isolate, to identify very quickly, very well. But it's very, very important. And why I try to show this for you, it's a new job. You can have money. Good money for me, Professor Roberto, because I say, of course, L'Oreal, Wanda, but I say, it's here, you can find similar. It's very, very important. Companies look for us for this information. But now about chemistry. Can you show just one slide with a very complicated alkaloids? The alkaloids. Can you come back? Just the students can understand. Because exactly, I said to Professor Shaw some class ago that when he showed about TLC.
Joãozinho.
Não, ninguém.
Okay. Lá nos alcaloides indólicos.
And I said that about TLC, it's very, very important. But not the same, but again, about metabolomics. If you're working with a several species, genus, of course you can find 1, 2, 3, 4 compounds in our analysis. We're analyzing about 50, 20 plants, 20 extract. Of course you find the new compounds.
Yes. What time you need to find?
You need to prove it. You need to analyze in the mind. I work with several students here, and you don't know the mind. I don't know why. Please don't think that you analyze only. Yes, no, because you have to understand where, but this structure. My student, I remember, they came with some compounds. I said, no, it's impossible. There is something bringing. How do you know this? Because you know how the class. You know the biosynthesis of the class. Then you can identify if the metabolomics gave you a structure, a long structure. And sometimes it's only the position of some acetate substituent or a more complicated substitute. But if we know the biosynthesis, we can look and say, oh no, it's wrong. And if you have a new compound, you need to prove it. How can you prove it? So many kinds of spectrum. Because look, it's very, very complicated class of compounds. You can't conclude one skeleton only with NMR or tortina. No. So it's bad. And Gilberto told me when I looked for Giba. Giba, there is a carbonyl here. Then he said to me, no, there is, I know the biosynthesis, I have a reaction in this position, I'm sure I have a carbonyl. Please, change some parameters, but please, I need this carbonyl so that I can prove this is my skeleton.
She's right.
Yes, yes, during my head. I think you need to learn and to see several classes, a complex class, but understand the chemistry, how, which one to convert in which one, so that you can understand when you have a very complicated NMR spectrum and you can identify new compounds. You need to know. I think, don't believe that metabolome give you everything. In my opinion, metabolome just this. Now you can start your project. Now you can the data to start your project. I think Vanderlan show excellent stuff.
She is trying to explain in this map. It's clear. If you know, this is a down that I showed you. It's like a botanist. Cut, like you have rocks separated by morphology, taxons, all information that you can see that was evaluated for plant species of animals or neighbors. So before this, I told all classes of alkaloids that you have here. If you know when someone go to my room and talk about one, in my mind, I remember what the class, what the species. If I know the family, species that is very small, but if I know the family, from the it's almost impossible. You have like tropan, like limonoids in Gentianalis. Even in Gentianalis, you can have iridoids that can be produced by pathway of the beans. It's completely different. So it's very important. When you see this map, if you have a study and you have idea about the taxonomic group and you know chemistry, you are be able, as you see where accumulate alkaloids, where you can accumulate terpenes like a calenol. It's very specific. It's not common. The only compound that is common for all that Professor report put. I don't believe it was not said Granada. I don't know. And flavonoid. Why? Professor only the flavonoid that's very important. It makes some. You have some blends to think about. Is C flavonoid or because you see flavonoid. Because most of flavonoid is a defense from the sun, for all that time in the earth. So, from humanoid to heaven, everything. From humanoid to não chega para humanoid, só se eu não entender, não serve para nada. Falta tudo. Falta tudo. E é verdade, porque tem tudo, porque o flavonoide é como se fosse um filtro para a preservação da natureza na Terra, de toda a radiação que vem, que é nociva. Então, é isso aí. Isso aqui é o que a falou.
Eu estava pensando assim, como o pessoal, eu conheço umas pessoas da área de botânica, como o avanço da técnica genética. Eles estão usando muito genética para resolver esses conflitos taxonômicos ali que eles querem. Mas aí eu estava pensando, então aquele da taxonomia clássica está condenada a ser extinta.
Não diria condenada a ser extinta, porque você não condena nem extingue área nenhuma. Mas essas ferramentas novas, logicamente, vão continuar principalmente porque agora, não importante para você, mas, por exemplo, lá em início, quando eu fiquei, olha, eu fiquei vários eu fiz 2011, 2012 e 2014. Eles têm uma informação enorme já de coisas que você pode utilizar para a botânica, porque lá tem um departamento de botânica muito importante. Porque essa botânica de só para ter conservação não é mais, não. Você tem ferramentas moleculares também para auxiliar a taxonomia. Eu não saberia dizer quais delas, porque a gente fica muito focado em química, mas tem avaliação de tecido celular, eles fazem uma avaliação muito rápida, de acordo com o tipo de célula que produz isso, que produz aquilo, isso já existe.
A química taxonomia nessa, ela volta para a nova roupagem, porque você tem todas essas técnicas que te permitem descobrir outros compostos que pertencem àquela classe, que até então a gente escolhia como por uma questão de quantidade, mas quando você analisa novamente a questão estrutural, mostrou a evolução do esqueleto, grau de oxidação do esqueleto, você novamente volta para a química taxonomia para mostrar se aquilo pode realmente estar concordando ou não.
Conhecimento é a coisa mais fascinante. E nem sempre tem que ser a coisa mais sofisticada, que é isso que às vezes as nossas agências de fomento não têm. Percebe esse trabalho belíssimo que a Helena fez, ela é brilhante. Ela tem um histórico escolar que a nota dela é 7,9. Aí faz, ela quer continuar, mas ela queria fazer sistemática também. Fotógrafo. A bolsa é negada porque não tinha novidade. Aí eu recorri, eu fiquei até pedir a paciência. Então, ela falou, não quero mais, porque eu vou para os Estados Unidos com o bolso, não fiquei prioridade. Aí, falando, e imagina, ela está na Califórnia, num grupo de primeiríssima, porque vocês conhecem, nessa história da modernidade das ômicas, trabalhando com esse foco de biologia molecular, o Peter está em um laboratório top. E ele era conquistado nos Estados Unidos. Aí eu não ia conversando, porque pediu a bolsa e ela foi com a bolsa Fulbright. Pediu, ela foi para lá, depois terminou e ele continuou dando bolsa para ela. A bolsa Fulbright tinha uma para 30. Aí no dia que eu fui ligar na faculdade, mas a bolsa Fulbright é muito fácil. Qualquer um ganha, eu falei, então vai lá e aplica você para ver se você ganha. Então, esse é o grande problema de um país que nós não somos uma república desenvolvida. Nós somos o país mais desenvolvido da América Latina, economicamente, cientificamente, tudo. Não é? Não, aí você diz, não é economia. Não tem jeito.
A infraestrutura, meu amigo, ele pode dizer que é verdade.
Qual é a infraestrutura que ele tem? Vai nos países aqui do lado, nós todinho vê se tem uma infraestrutura do seu laboratório. Então, um laboratório top, viu? Eu não digo de ponta para manter os 600 lá toda hora. Então, toda a ciência hoje, competitiva no mundo, ela é extremamente cara, porque tudo em dólar. Tudo. E o que aconteceu com o nosso país? As pessoas não têm noção. E eu espero que meus jovens, lindos, maravilhosos, sejam cientistas, mas também sejam intelectuais. Eu já falei com meus alunos que não basta ser ralador de bancada. Porque você tem que entender, ter uma noção do mundo atual, do seu país, para você contribuir. Eu acho que as cabeças jovens têm tanta coisa para contribuir nesse país, para a gente mudar. Porque se você não muda, cada dia mais, por exemplo, a Dilma era meio desajustada mesmo. Ela sofreu impeachment, porque disse que não investia, era 5,2 bi. Ela assumiu, porque foi caindo desde que o governo não fez. Eu sei desses dados por causa da Sociedade Brasileira de Progresso da Ciência, que eu fui vice-presidente. Tá? Eu fui mandado embora também. Aí tem. No governo Bolsonaro, chegou a 2,1, menos da metade dela. E ele não foi sofrer impeachment. Tem um problema aí de machismo? Tem. Um país machista. Tudo bem. Mas tem que ter um olhar. Um país que vestia 12, chegar agora, pode ter quem tem, não tem dinheiro. Por mais que estão tentando pôr os trocados lá, não tem. Você não pode imaginar a quantidade de jovens brilhantes querendo entrar no sistema do CNPq, tudo com índice H30, com índice, não estou falando do nada, estou falando do todo. Índice H30, fim de não sei, tudo jovem entrando no sistema. E não tem como marcar, porque o sistema está cheio de velho, com 12, com 15, com isso e outro. Tem que ter um olhar. Não estou dizendo que tem que colocar a velharia para fora, não. Estou dizendo que tem que ter um... Eu sou velha. Tem que ter um olhar para essa juventude que também foi o Estado que investiu. Sabe por que o Estado investiu? Quanto custou? E agora nós estamos fazendo o quê? Bom, a Russo só volta se for necessário, porque não sabe se volta. A Mary tinha uma bolsa para pesca desse tamanho, largou a bolsa, não quis mais, porque ficou na Austrália. O outro ficou lá no centro, todo mundo dentro. Ó, o Brasil investiu, a maioria estudou em escola pública, primeira qualidade. As custas de todo, não é só o rico que paga, o pobre também paga para a gente estudar. Aí, fizemos a graduação, mestrado, doutorado, pós-doc 1, pós-doc 2. Aí, esse povo tudo bem formado, não tem lugar, vai todo mundo embora. E aí a gente precisa criar uma mentalidade que ela falou, vocês. A felicidade não passa por estar na universidade. Tem um bando de empresas hoje pagando muito dinheiro, muito bem, quando compara com o nosso salário de início de carreira, para fazer coisa bacana também. Eu estou falando, existe vida virtuosa fora da universidade. Não vou falar mais. Eu deve estar morrendo de sono.
Let's go for lunch.
Muito obrigada, Marcelo. Obrigada a todos vocês estarem convidados.
Semana que eu venho gravar um novo projeto, ver as apresentações que era bem meus alunos. É uma nova ideia, fazer outra coisa nova. Uma molécula pequenininha assim, ó, não lembra? Ah, mas eu vou acontecer isso. Uma molécula pequenininha, eu posso. Ok, obrigada. Thanks a lot, second, please. Okay.
É só propriedade, né?
Yeah, no. The colleagues from YouTube, we finish now the professor lecture conference. I could I wait you could understand the sequence of the Professor Shaw course and why I invited the Professor Vanderlan exactly to close the Professor Shaw course so that you could stimulate it to use metabolomics and you can attract more students for chemosystematics. And thank you a lot for you stay with us in YouTube. And please, I remember you in the afternoon. We are here in the same place again for a workshop with some lectures from Professor Shaw and the other invitees, and they are talking about them results. Okay? Okay, we start again at 2 o'clock, please, in the same place here. We are here, and who are virtual, please see you again at 2 o'clock.